Welcome to your security journey. My name is Michael Birch. I'm the Director of Application Security, and today I want to talk to you about the software supply chain security. Now, this is a topic that I've done a big deep dive, looked at a lot of resources from, and one of the big things that I want to do here is call out the actual complexity of the software supply chain well beyond what the traditional ideas of it might be, as well as call out some of the resources we can to ensure that we're applying those resources to create a bit more secure environment. I want to start off with talking about what is the software supply chain. Now, traditionally, a lot of people think the software supply chain is just the dependencies that I'm allowing into my application and managing those and security vulnerabilities, because those are the supplies that are being brought into my application to help build it out. Now, we need to reframe that idea about what software supply chain is. It's much more comprehensive, and a lot of the tasks we need to be doing to secure it go well beyond just thinking about our dependencies. It starts with source code and our dependencies, understanding the difference between our commercial off the shelf versus our open source versus what we're writing ourselves and how those all work together and how we're securing those. But it also involves all the tools that we're using to develop. It's our IDEs, our build tools, our pipeline setup. Has to do with any third-party services and APIs that we're actually bringing and leveraging to use our application. Has to do with the infrastructure that our platform is actually being hosted on. You could even consider part of the distribution deployment and how we use package managers or where we're actually hosting these applications, as well as how are we monitoring? What tools do we have set up to monitor performance and security? The way that we should relook at the software supply chain, it's not just the components that we're including. It's everything that goes from the moment we start either building or including a piece of software into our application. And when that software itself, if it's a third-party solution, open source solution, how it began, all the way to now it's live in our application and all the tools and processes and everything that happens to those components and that software as it goes along its journey from ideation all the way to production and into our customers' hands and how we're actually monitoring that. When we reframe the thought process of that as our supply chain, that is what we have to secure. This conversation becomes a lot more in depth and it starts to make a lot more sense why this is such a hard thing to manage and keep secure. Because as you see along the way, all of these become points of failure. All of these become attack vectors that can be targeted to either disrupt, pollute, inject, do something malicious to our applications, our software, our products. So now that we have a better frame of mind of what the supply chain is, let's start talking about some terminology I think that's important to understand when discussing these things. There's two terms that are thrown around a lot. There's provenance and pedigree. Now, between provenance and pedigree, these are very similar terms. A lot of what they mean can be kind of convoluted. There's a lot of different opinions on how these are actually defined. I actually went and looked up some scientific definitions when you think about pedigree, like the pedigree of an animal, right? Their history and lineage versus like the provenance is where did it come from? Where's everything about how it's gotten to where it is? And you see a lot across the community that people either mix these up or they use them interchangeably or there's some mistake in their implementation. One thing I would like to call out that I think it's less important understanding which word means which. We understand what they're trying to do and understand how we're trying to apply appropriate steps to do those things. And as I go along and talk about some of our resources, I'll talk about how some of the people define this. But for my general definition between the two of these, generally provenance is going to be the idea of where did the code come from, what was its development history, its build processes, any dependencies that are built into it, versus like the pedigree is going to be more about creating an audit trail, a certificate of compliance. It's like the quality of this, the chain of custody quality side of it. Chain of custody can kind of bleed into both sides of the provenance and pedigree. But the important part is that both of these are trying to identify the source of the software and everything that's happened to it along the way. And by looking at where it came from, evaluating how we got that software, how it was built, where did it come from, what's built into it. And then we also track everything that happens along the way to it, whether we make a version change, we update, we delete code, anything, any tool that touches it. As long as we have that chain of custody record, we create a very in-depth audit trail that we're going to be able to use, as well as it's going to enable us to react quicker when known vulnerabilities come out, or do a retrospective when something happens and we have to understand what went wrong. Having these built-in provenance and pedigree, whatever term you use here, is important to apply those concepts. Now, one of the other things I want to talk about, this really comes into some of this, is the software bill of materials. Now, there's a lot of talk and I think misnomers of what a software bill of materials is, right? So for formal definition, real quick, it's the formal record containing the details and supply chain relationships of various components used in building software. Now, how do we apply that to a practical sense? Well, one of the two of the things I just talked about was provenance and pedigree. How do we capture that information of the software? How do we build that provenance and pedigree? How do we capture in one location that's going to be in a format that's usable not just by people, but by tools? Because manual processes are the anti-pattern of security. Anything you can automate into the process, the better. That way it's repeatable and it's structured and it's done the same every time. And it also communicates well with others, right? Other tools, other products, other processes. But the main takeaway here is this is that key component that you can use to help understand what is building, what's in your software, what components are there, everything that's gone into it, as well as where it's been along the way. If you do this right, you will build in that audit trail, that provenance, that pedigree, that deeper understanding of what's going in your application. Now, what are some of the benefits for this? First of all, you're going to prevent known vulnerabilities. That's one of the big ones. Is if I have to justify and understand every piece and component that's going into my application, third party, open source, proprietary, and a known vulnerability comes up, I should be running tools against my SBOM to identify these known vulnerabilities in certain versions of releases and everything else so I can react to them. So I'm not including known vulnerabilities, so I can put mitigations in place. Helps manage licenses. Licenses can be difficult sometimes. Now then, we're using open source components, but it doesn't mean we can use them however we want just because it's open source. Open source isn't carte blanche, just take it and use it however you want. There's different licensing levels and different ways you can use these, and using SBOMs can help you manage that and understand what the licensing requirements are for the components you're using. Also helps you do compliance requirements, whether when you have to justify and go through an audit, these really help. It's going to help you manage your mitigations. If you have that understanding of all the changes that's happened in your software, you can actually have a catalog of all the security controls that you've in place to ensure that software is secure. It's going to improve your efficiency. It's going to improve your efficiency and response times, as well as make you justify every piece of component that's actually going into your application. It's part of quantifying risk, is understanding the components you're adding, the risk they're going to add to your software, and then having to document, capture, understand what's now there, right? One of the things I would do like is especially incident response. All of a sudden, a big vulnerability is out in the wild, and now we all have to react. We have to say, hey, do we have this component in our applications? And is it in one of our applications? Is it across a bunch of our different business units? Like how can we find where this one vulnerable component might be throughout our entire ecosystem? If we have these good SBOMs, if we have this good provenance and pedigree and understand what's in all of our components, we can run tools to immediately find quickly exactly where that component might live throughout our infrastructure, and then we can start taking steps to remove, to update, to patch, to respond much faster and in a much more organized, controlled fashion, rather than playing whack-a-mole trying to find where this vulnerability might exist. Now, one of the places that I actually leaned on heavy, and I have to give them a great shout out for the amount of amazing information they have, is the National Telecommunications and Information Administration. They have done an immense amount of work about talking about what software bill of materials are, how they work, how to build them, the tools. And I'm actually going to jump out of my presentation really quick, and I want to share some of their stuff. And let's jump off on the wrong page real quick. Here we go. So they have an entire section on their website that does a deep dive into software bill of materials. And this goes into what are they, how do they work, how do you mitigate some of the different facts and myths. Excuse me for a second. And it really deep dives into telling you what these are and how to use them. One of my favorite sections actually is going into their facts and myths, because they deep dive into things that are like, hey, aren't they a roadmap to the attacker? Well, actually, they're not. Most of the time, the attacker has tools where they can go in and find out what's in your components and do they have tools they can glean this information anyways. But one of the biggest problems is often the defenders don't have a good list of the materials going in there, so their ability to react is inhibited, where not the same way that the attackers are, right? It's much more reactionary. It's better to level set everybody. And also, you don't have to share your SBOMs with everybody, right? That's something that you can have internal information in your SBOMs. Just because you're creating one doesn't mean you have to publish it everywhere. And there's different ways you can do that, right? But in certain cases, you do need to. But you also don't have to put proprietary information. Just because I give you all the ingredients to a recipe, I hand you all the ingredients in bucket and say, go cook. If you're not a cook and you don't know how to use the ingredients or how they go together, the best times to add them or cook them or what approach to take, doesn't matter. You know what's in there. You still can't make the actual soup unless you know what you're doing, right? Unless you know how they all work together. So by having a list of ingredients isn't necessarily a roadmap for the attacker, but it can definitely help the defender. There's a lot of myths like this around what SBOMs are and how they should work. They do a deep dive into each one of these. So I highly recommend it. Anyone that's looking into this space, looking at the software supply chain, this is a phenomenal source. And actually, I want to call out one of their favorite things they actually have in their document. They created this amazing graphic, and I think it really captures how an SBOM can be leveraged throughout the life cycle of a software supply chain. It starts with your everything, right? So we start from the install, configure, maintain, plan, procure, develop, build, test, release, right? So that's the life cycle. And then all of a sudden we talk about, okay, what should we be capturing? And what are the things that might change in our application that we should understand and should be involved in our SBOM, right? So as we go through and we actually do these different things, we can identify different risks. We're doing monitoring, right? We're looking for risks. We can capture potential CWEs that might affect the software. Whenever updates are added, third-party components are added, whenever there's something that we use to build or patch or compile, we capture all that information along the way. And then all of a sudden we can put it together into having this deep understanding of everything that's happened in the software's been through. So if there are problems, we can catch them early, and we actually have an understanding. One of the biggest things I call out there, and it's a concept that we hear in security a lot. You cannot defend what you do not know you have, right? So whenever you roll out a security plan, one of the first things you do is you get an inventory of all the stuff you need to actually start defending and securing and controlling. SBOMs allow us to do that at the software level. So definitely, I know a lot of people talk about, like, there's a lot of talk about whether these are valuable or not. They're valuable. Understand how they work. Understand how to apply them. And also understand there's a lot of tools. That's one of the other things I like to call out. There's a lot of different tools that you can use to build these out. And this website does a great job of talking about those. You have tool classification, right? So there's not just one tool. There's a handful of different tools that you can use to leverage against your SBOMs. And there's a lot of different formats for your SBOMs. You got to do a deep dive and look into what's appropriate for you. But understand there is value in SBOMs. Look into them and apply the right practices to do that in your organization. Another place I'd like to call out that has a lot of information on SBOMs and BOMs is the Software Component Verification Standard website. They actually have an entire section called the BOM Maturity Model. And the BOM maturity model, it says exactly right here. It's a formalized structure in which bill of materials can be evaluated for a wide range of capabilities. So it's basically, how can I evaluate my use of my software bill of materials, how I'm applying it, is it doing the things I need it to do? And it breaks it down by difficulty levels to obtain in the practices, different supporting levels, as well as it deep dives into the taxonomies and the different type of structures that you should see in your actual software and the different things that can go into it and say, hey, this is a low difficulty and exactly what you should be doing, right? So definitely another great resource when talking about using software bill of materials. Now, next thing I want to go is I'm going to go back to my presentation. And that brings me, I already brought this one up. The OAuth software component verification standard, BOM maturity model specifically there. Go check it out. It's definitely, once again, you're looking at securing your supply chain, a very important resource, and anything pushed out by OAuth usually has a ton of value, so worth looking into. The next one I want to talk about is actually the software component verification standard itself. It dives in, we're going to go back to the website and look here in a second, but it dives into these 6 different approaches to securing the side of the supply chain and talk about, hey, how do you do your inventory? How do you actually leverage software bill of materials and what you should be doing at different levels? How do you secure your build environment, package managers, composition analysis, and pedigree and provenance, something we brought up early on. One thing to call out here again is even coming from OAuth, they're looking at that comprehensive cradle to grave, everything that goes into and can affect your supply chain. So when we look at these, one of the things we should be looking at is, let's go back over to SVS. This is their main website. You can jump in, get started, jump right into their different verification levels and standards. One thing I would like to call out too is using this. They have different, they call these control families. These are different groupings of activities you do, but they're also broken down by level. So at level 1 is basically everyone should be trying to do these. This is for everybody. Level 2 and level 3 is depends on the maturity of your organization. And it also depends on how secure you need that actually application to be. The higher assurance requirements for super sensitive data, you should be going for that level 3. If it's a lower risk component, and then you might not need to apply all the way across to level 3 for that component, right? It's risk management. We understand that sometimes we accept risk. We just don't ignore risk. That's the biggest thing right there. Acceptance is a form of risk management. Now, they deep dive in a lot of different things. Inventory, first thing, like we said, we're like, hey, you have to know what you have. And one of the big things that calls out here is components are available in a machine readable format. That really builds into what is software bill of material is, right? Software bill of materials should be in a machine readable format. It actually goes into talk about how your software bill of materials are basically evaluated to their quality. It kind of follows along with the BOM maturity model, but it has very specific practices and it maps them to the different levels that you're trying to achieve. Deep dives into your different build requirements, talking about the build tools and your pipeline, package management, and the different type of repositories you're actually pulling your packages from, and practices do that. This has a lot to do with even having on-prem repositories so that you have a barrier between the exterior components and interior components. We have component analysis requirements. This is deep diving into understanding the quality of those components and where they are and how they're living, and using tools to evaluate them. A lot of this is about tools. So this is software composition analysis, running automated processes to identify vulnerabilities and problems within the components you have in your application. And it ends on, like we said before, the provenance and pedigree, making sure that you have that chain of custody, that you are paying attention to this and actually documenting when and how changes and modifications happen, and at a precise level to have a deep understanding of what's happening there. So great resource, definitely about talking about the different maturity levels and how your organization lines up to how they're doing supply chain security now, and then how you can move forward and gain traction to do secure supply chain practices in the future. Now, the next one I want to call out is the Secure Supply Chain Consumption Framework. And this is coming from the Open Source Security Foundation. They're actually a great organization. They do a deep dive in a lot of things about open source security in general. And they actually created this framework to talk about how you can safely consume these supply chain components, especially specifically for things like open source software. Now, the things that I love about theirs, and keep in mind, this is just another standard, another resource that you can apply in your tool belt, right? So we have the OWASP SCVS. We have a lot of information coming out from other government agencies about how you handle SBOMs. This is another resource. Jumping over to their website, repositories where it lives, you can actually jump right in. You want to go, you can basically read about the project, love their icons. And the motivations, objectives, how to apply it. They have a lot of guidance in here. But you want to jump in and see exactly what they're putting out. You can go jump right into specifications, and then you can jump right into the framework. Now, the framework's going to basically have the simplified requirements and then deep dive on how do you kind of apply those different things and how you evaluate. They also do a lot of levels also. So they do the same type of process where you actually have different levels of maturity that you're applying for different scenarios. So a good example is their categories are practices. They're going to start with a practice. They're going to tell you exactly what that practice is trying to accomplish. And then later on, they're also going to talk about the different levels, right? So their system is a 4-level system instead of a 3-level system, but the process still maintains pretty well the same. Where at level 1 is basically what everyone should be doing. And the higher up you get, it depends on the maturity of your organization as well as the sensitivity of what you're trying to protect. So let's jump in and look at some of their frameworks. So the first part is ingested. This is actually how this practice is how are we consuming software, right? And it's to tell you, hey, these are the things you should be doing. You should be using open source software binary repository manager solutions. So these are actual repository manager solutions rather than just necessarily going out and grabbing a package and throwing in the project yourself, right? Use the tools that are there that can help you do some additional things like they're going to allow you to run some additional tools, and they're going to have some feedback on when things are out of date and other things that you might not do if you're manually doing this process. Scan, it's a big one, just like we were talking about in the SCVS. This is talking about scanning not only the components for vulnerabilities, but things like we talked about earlier, like licensing and understanding if it's end of life or if it's still being supported. That I think is a really impactful thing, is to understand if a component you're using is end of life, you need to understand that now you need to do something. Usually the reaction is you either need to replace that component or accept the responsibility that you have to maintain that locally now. Inventory is a big one, understanding what you have. Helps with incident response plan, right? So have an open source software incident response plan. This goes back into understanding, okay, how are we going to leverage our SBOMs? How are we going to react and have a plan in place already, just like you would have with any incident response plan, but for how your components are being when they're impacted. How do you keep them up to date, right? This is a big one, like making sure that you have the proper way to keep it update and that you're doing it and keeping updates so that you're preventing vulnerabilities, but you're also doing it in a secure manner. So one of the big ones I like here is 2-person peer reviews are enforced, right? So this isn't a 1-person process. You have somebody review it before you can push. We do that already most of the time, or you should be when you're writing software, is having someone review it before it goes to production. Your component should be the same way. It shouldn't be the Wild West where anyone can just add whatever they need or update a component without somebody else looking at it. Audit it. This goes back into validate your SBOMs. Create that provenance and pedigree and make it so that you're not only auditable from external sources, but for your interior sources too. So people can do interior audits and get ahead of problems before they become a problem. This one I really like, this call out, which I didn't see in a lot of the other ones. Let's talk about enforce it. There's one thing to have policy. There's one thing to say, hey, we should be doing this and we've written out and this is our policy and this is what we're doing. It's another thing to actually enforce that the things we've created, these systems and processes, are actually happening. And that's where this really kind of deep dives into. Two of the last ones I want to talk about, rebuild it is a good one, right? Being able to digitally sign the OSS as you rebuild it locally so that you can host it separately so that you're reducing your attack surface. But by far my favorite is the fix it and upstream. This is talk about not only when a problem happens, that you are able to fix or address that 0-day vulnerability, but then afterwards, if you find a vulnerability and you are one of the first ones to discover it and you can make a change to fix it, inform upstream, allow the person who hosts that component, allow the organization or the group of people or the individual that is allowing you to use these components of software in your application, let them know there's a problem and let them know how to fix it. It's responsible disclosure. It's not just the legal thing to do. It's the ethical thing to do. Give back to the community that's giving you so much. So those some big different things to talk about there, but I wanted to really just kind of highlight in total a lot of the different resources that are out there. Software supply chain goes well beyond the thought of, okay, I just got to look at the components I'm downloading. Do they look legit? Oh, they look legit. We asked a few questions about the providers and we moved on. It is so much more about understanding everything that software goes through from the moment you decide to use it and capture that in a good machine readable format, and then apply security controls along the way to ensure that it's not being attacked or modified or disrupted in any way from the time you decide to use it to the time that you're actually implementing it. Because that's not only going to increase the quality, it's going to reduce the amount of vulnerabilities that end up in your system and the amount of times you have react, and it's going to increase the confidence that your customers have with you. If you are going out to a vendor and you're going to use their software, one of the number one questions is that even before I use an open source software and include my project, do they have an SBOM? Because if they answer straight no, that tells me right now they're not tracking provenance and pedigree. They're not accountable for what's in their software. They're not thinking of software supply chain security. So be that thought leader in your organization. Start pushing for this. Create the SBOMs. Create that transparency. Create that confidence in your customers that your software is secure. And this is something you're thinking about. And one of the best ways to do that is by going through these processes, looking at these frameworks, seeing how you compare to them, and then start applying the practices they ask you to do. So I hope you guys had a great time listening to this conversation. Super passionate about software supply chain stuff right now and into the future. And I hope you guys got at least some places to go look for further information on this topic. So, and always remember, security is a journey, not a destination.